Before we start talking about division of integers, let's review our integer poetry that we've learned so far. Can we put them all in order, plot the points, and we just might, because the number that is greater is the number to the right. Opposites are easy, just switch the sign, or go the same distance on the other side of Mr. Numberline. An absolute value is happy, it feels like a hero, because it's the positive distance of the number from 0. If the signs are the same, then that's simply divine. Add the absolute values and keep the sign. If the signs are different, you need to take charge, do big minus small, and keep the sign of the large. If the problem is subtraction, then you know your mission. Change the problem to addition. You've looked forward to this since integers beckoned. Change the minus to a plus and change the sign of the second. If the signs are the same, in harmony they live. Everyone is happy and the product is positive. If the signs are different, they don't act like adults. They fight with each other with negative results. So what do you think the division poetry is going to be like? So let's talk about dividing integers. Let's start with reasoning about division. We know, and we did not do these warm-ups, but you should know, that if 4 times 3 is 12, and then you've got a fact family, 12 divided by 4 would be 3, and 12 divided by 3 would be 4. So if we know these fact families, and we've been learning these for a very long time, we only need to extend on this concept to negative numbers, and then we're going to get our poetry for division. So to determine the rules for division of integers, we're going to use this inverse of multiplication rule. So let's keep practicing from where we left off with multiplying integers. If 4 times negative 3 equals negative 12, and we did the fact family for this, and we did negative 12 divided by 4 should get us negative 3, based on our knowledge of fact families. And vice versa, negative 12 divided by negative 3 would equal positive 4. What about if you had negative 4 times negative 3? Since the signs are the same, the product is positive. So we could assume that 12 divided by negative 4 would equal negative 3, and 12 divided by negative 3 would equal negative 4. Are you seeing a pattern here? Let's go back to multiplication and review. In 2 times negative 5, our signs are different, so they don't get along, they fight, and the product is negative. So that would mean that negative 10 divided by 2 would be negative 5, and negative 10 divided by negative 5 would be positive 2. What about negative 2 times negative 5? The signs are the same, so the product is going to be positive. So that would mean that 10 divided by negative 2 would result in negative 5, and 10 divided by negative 5 would result in negative 2. This is actually all the information that we need, and we can look at the results above, and we should be able to figure out that the quotient of a positive and a positive is always positive. You've been doing that since you learned division the whole time. So you should know a positive divided by a positive is always positive. The quotient of a negative, or of a positive and a negative number, is always going to be negative. Just like in multiplication, when the signs are not the same, they don't get along. And vice versa, a negative divided by a positive. All that's changing there is which number is the dividend and which number is the divisor. And it doesn't matter. If the signs are different, the answer, the quotient, is going to be negative. And then if you have two negative numbers being divided, a negative divisor and a negative dividend, your product is going, or your, quotient will be positive because the signs are the same. So if you look at the rules for multiplication, you should notice that the rules for multiplication and the rules for division are exactly the same, which is awesome. This brings us to our poetry for division. If the problem is division, You need make no new decision because the rules for multiplication are the same as for division. Go ahead and take a quick second and pause the video and complete letters A through F. Take a second and check your work. Again, if the signs are the same, the quotient will be positive, and if the signs are different, then the quotient will be negative. Remember that there are many different ways that we can write the division sign. You have the normal division sign, you could write a slash, or you could write it as a fraction. All of those mean division. Also, remember the rules regarding 0. If 0 is the dividend, you get 0 because there are 0 groups of -5 and 0. However, 0 can never be the divisor. So right here where you have 0 as the divisor, we call it undefined because no matter how many groups of 0 you have, you will never get -5. So we never want to have 0 in that divisor place. So one last time, if the problem is division, you need make no new decision because the rules for multiplication are the same as for division. And that rule is the same sign results in a positive quotient and different signs will result in a negative quotient.